Hello. Today I want to give just a very short introduction to modular arithmetic and harmonic astrology. So let me see if I can share my screen and we'll get started. Okay, it takes just a minute here to get everything set up. And I've got to get rid of some panels so I can see what I'm doing. So just bear with me a little bit longer. Almost there. And we're ready. Introduction to Modular Arithmetic and Harmonic Astrology. So, what is modular arithmetic? That's the big question and what we will focus on today. Well, modular arithmetic is what most people know as clock arithmetic. For example, if we add 4 hours to 9 o'clock, we don't get 13 o'clock. Instead, we start over once we get to 12 o'clock. Thus, 9 o'clock plus 4 more hours takes us to 1 o'clock. In astrology, we can think of our 360-degree zodiac as a 360-degree clock. Hence, we measure all angles as lying between 0 degrees and 360 degrees. In particular, an angle like theta can be greater than or equal to 0 degrees, but strictly less than 360 degrees. Once we get to 360 degrees, we just start over with 0 degrees. Okay, if we have an angle such as 420 degrees that is larger than 360 degrees, then we just keep subtracting 360 degrees from 420 degrees until we get an angle within the proper range. In particular, since 420 degrees minus 360 degrees is 60 degrees, on our zodiac clock, 420 degrees is equivalent to 60 degrees. And we express this by writing that 420 degrees modulo 360 degrees is equal to 60 degrees. This modulo 360 degree part, this tells us we're dealing with a 360 degree clock. So once we do a complete rotation of 360 degrees, we start over. And when we start over, we have just 60 degrees unaccounted for. So 420 modulo 360 is equal to 60. Now, in general, if we have an angle theta that is greater than or equal to 360 degrees, then we can find theta modulo 360 degrees by either repeatedly subtracting 360 degrees from theta until we get back something in the proper range, or we can divide theta by 360 degrees and look to see what the remainder is. So using the subtraction method, I can subtract off 360 degrees twice, and I'm left with 10 degrees. So 730 degrees modulo 360 degrees is equal to 10 degrees. We're subtracting 360 degrees twice from this 730 degrees that I'm using as an example. Using the second method, we could divide 360 degrees into 730 degrees. That goes twice, but leaves us with a remainder of 10 degrees. So 730 degrees modulo 360 degrees is equal to 10 degrees, once again. Okay, in particular, note that 360 degrees modulo 360 degrees is equal to 0 degrees. And you can verify that by using either the subtraction method or the division method. Okay. Now, usually we will be dealing with positive angles, but if we have a negative angle, such as negative 60 degrees, that's less than 0 degrees, then we keep adding 360 degrees to this angle until we get an angle within the proper range. In particular, since negative 360 degrees, negative 60 degrees plus 360 degrees is equal to 300 degrees on our zodiac clock, negative 60 degrees is equivalent to 300 degrees. And we express this by writing negative 60 degrees modulo 360 degrees is equal to 300 degrees. And in general, if we have an angle theta that is less than 0 degrees, then we can find theta modulo 360 degrees by either repeatedly adding 360 degrees to theta until we get back something in the proper range, or we can divide theta by 360 degrees, find the remainder, and add 360 degrees to the remainder. Now we have to do this additional addition because if theta is a negative angle, and if we have a non-zero remainder, then that remainder is going to be negative. So you have to add 360 degrees to it to get something back within that range from 0 degrees to positive 360 degrees. Okay, and here I find negative 90 degrees modulo 360 degrees using both methods. First, I could add 360 degrees to this to get 270 degrees, or I could divide negative 9 degrees by 360 degrees. That gives me 0 with a remainder of 90 degrees. But then I have to add plus 360 degrees to that negative 9 degrees in order to get 270 degrees. But either method will give you the same result. Okay. Now, in mathematics, the numbers 1, 2, 3, and so on are called counting numbers or natural numbers. They are obviously the numbers we count with. We call them natural numbers because we think of things in nature as occurring in these quantities. If you're counting trees in a forest, you don't do, okay, one tree, but this one's really big. So that's like 4.5 trees, and this one's small, so it's just a third of a tree. You don't do it like that. Regardless of size, you count things in nature like 1 tree, 2 trees, 3 trees, etc. So we can call these counting numbers or natural numbers. I will usually call them natural numbers. And in proofs for harmonic astrology, we often encounter expressions of the form n times 360 degrees plus 25 degrees, in parentheses, modulo 360 degrees, where n is a natural number. And in an expression like this, up here, the n times 360 degrees contributes nothing to the final result, since its remainder when divided by 360 degrees is 0 degrees. So hence, if you see something like n times 360 degrees plus 25 degrees, where n is a natural number, and this is all modulo 360 degrees, you can just strike out this term, just ignore it. This simplifies to just 25 degrees modulo 360 degrees, which is 25 degrees. Okay, and that is going to be it for this little presentation. So I'm back. That was short and sweet. And I hope you watch some of the other presentations I've done for my series on essential theorems for harmonic astrology. Okay, well, that's it for now. So I'll stop recording. I'll just say so long and be well.